Good afternoon, and welcome to the Sustainable Materials Management webinar series, a joint effort between the National Recycling Coalition and the Pennsylvania Recycling Market Center. My name is Wayne Bowen, and I'm the program manager for the center, and I will serve as the moderator today. We would like to extend a special thanks to Bob Hollis of the Mobius Network for providing the webinar management software for this series, and Lisa Ruggiero of the National Recycling Coalition for providing technical support. The subject of today's webinar is recycling and life cycle analysis. We have two excellent presenters today, Ann Johnson and John Detling, who I'll introduce in a moment. Following their presentations, we will conduct a question and answer session. If you have a question or comment, please use the GoToWebinar dialog box located in the control panel on your screen. You may also use the dialog box to request assistance if you're experiencing technical difficulties during the webinar. And now I'd like to introduce our presenters. Ann Johnson is Principal and Vice President with Resource Recycling Systems, where she is leading their new corporate sustainability practice. Trained as an engineer and scientist with a background in management and sustainability consultant, she has more than 20 years of experience in materials, industrial processes, environmental management, and systems evaluation of products and packaging. Before coming to RRS, Ann worked for the sustainability nonprofit Green Blue and was the director of Sustainable Packaging Coalition. She has been a technical advisor to the Consumer Goods Forum Global Packaging Project, as well as the US EPA Sustainable Financing for Municipal Recycling Dialogue. She currently sits on a variety of advisory panels, including the board of Keep America Beautiful, and is very interested in extending her work to emerging markets to address the growing food and waste problems associated with these rapidly growing economies with underdeveloped waste management infrastructures. John Detling is the U.S. Director for Qantas, where he provides decades of professional experience in leading applications of life cycle assessment, chemical management, and environmental impact assessment with leading public and private sector groups. Mr. Detling has been a member of working groups under the World Resource Institute's Greenhouse Gas Protocol, of the Sustainability Consortium's Measurement Science Working Group, on the steering team for the Global CEO Forum's project on packaging, a reviewer for the International Journal of Life Cycle Assessment, a member of IEEE's Green Engineering Editorial Board, and a member of the Technical Committee of the American Center for Life Cycle Assessment. He has worked with a diverse range of leaders in public and private enterprise, including such organizations as the World Business Council for Sustainable Development, the Environmental Defense Fund, Pfizer, Steelcase, CalRecycle, Kraft Foods, Intel, and many others. He holds a master's degree from the University of Michigan in Environmental Health Sciences. Welcome, Ann and John, and I'll turn the program over to you.
Wayne, thank you very much. I'm very pleased to be here and delighted to be presenting with John Detling. He's been a longtime colleague and quite an expert on LCA. John and I had talked about how we would, pursue this presentation for you all. I'm going to put in a quick plug for Resource Recycling Systems. We are a consultancy that has worked for over a decade working on both the design implementation of creating infrastructure for resource recovery systems. We work on both municipal and corporate sides of resource recovery. I have recently joined RRS on developing a corporate sustainability practice for them, and our expertise spans from both engineering well into management consulting, and encourage you to visit our website to see sort of the range of activities that we do. But I've been most impressed joining RRS at sort of the broad range of recovery expertise that is resident in RRS. So with that, we're going to move on. John, are you there?
I am. Can you hear me?
Yep.
Okay. Maybe just a very quick introduction to Qantas. Qantas is a global team of consultants specializing in LCA. We work with a pretty wide range of clients, including in the private and public sector, and have teams both in North America and Europe.
As John and I were thinking about how we would go about, really talking about how recycling and LCA work together, we thought, not knowing what our audience knows or doesn't know, we would start with really a sort of basic primer around life cycle thinking and go through design and design for environment and some of the basics of that, and go into a little bit around design for recycling and how life cycle assessment can be used to answer some of those questions around design for recycling, and really give a basic introduction around life cycle assessment, and then have John give, I think, some more in-depth details about really going into some case examples of how LCA is used by case examples of when we use LCA to really as a tool to make informed decisions on life cycle management issues. So that's sort of our agenda for this presentation today. We thought we'd each take about 20 to 25 minutes and then leave plenty of time at the end of our presentation for questions. So we hope you'll have lots of them at the end. So with that, let's get started. So I wanted to start really thinking about, as designers, when we do product and packaging design, what is the typical sort of heuristic when we do product and package design? What do we usually focus on? And the typical niche is typically around consumers. The focus is usually on what do they want, what do we need to do to have a product and package sell to consumers. It's a pretty narrow focus, and that's been typically what we focus on as product and packaging designers. But as design for environment has become a bigger and bigger issue for designers, our range of issues has expanded. And the question has become, how do we really sort of wrap our arms around all of the varied issues that we consider? So as we go way back into sourcing issues, some of the types of issues we start thinking around sourcing of materials, there are very intense local impacts associated with raw material extraction. We might be worried about biodiversity impacts, land use conversion impacts. We also might be interested in the use of recycled materials. Design for environment also suggests that we would consider manufacturing impacts. Those include emissions, whether there are regulatory issues, or in some cases in global markets there may not be regulatory issues around manufacturing. We may have toxics issues, and increasingly we've looked at both the quantity and quality of issues in manufacturing. And we also consider use phase issues. Depending on the product, we may consider how durable is the product. Does it have a short life cycle? Does it have a long life cycle? Are we talking about a durable good or a fast-moving consumer product? Is a lot of energy used during the lifetime of this product? Is it a consumptive use product? Or is it something that it could be a product of service? Lots of different types of questions we might ask about the products that we're designing for. And then we get to perhaps questions as designers that we have at the end of life. How are those products going to be managed at the end of life? Are we going to recycle them? Increasingly, we have different options for how we could manage those products at the end of life. If we're in some markets, maybe chemical recovery is an option. Waste to energy, waste to fuels is increasingly an option. Could we compost those products and packaging? Or in the U.S., maybe it's just going to be land disposal, landfilling is an option. So when we look at design for environment, we have a huge array of possible issues that we might think of. And the problem is we look at each of those little niches. By looking at any one niche, we don't really get a very good holistic perspective of what's going on across that perspective. What we want to do is take a life cycle perspective of what is the entire perspective of that product and package that we want to design for. We want to be asking questions across that entire system and take a very holistic perspective of the life cycle of that product and package. And that's a pretty sort of overwhelming task, actually, when you think about it. And the first thing that we need to do as designers when we think about that is, what are our priorities? What are the first things that we want to say are most important to us? Are we going to design to minimize greenhouse gases across that life cycle? Are we going to design for specific end-of-life issues? And how do we know that we are going to be making the best decisions? What tools are out there that can help us know that we are making the best decisions? So that over the last, 10 or 15 years, those have been some of the questions that people who have really been working in the space of design for environment have really been working on. And one of those tools is really life cycle assessment. So as designers, we've really begun to take a much more holistic perspective of the design space and really begun to think, where is it where we have leverage? What is it that we can influence as designers? Because as designers, we don't have a lot of influence on some areas. For instance, in sourcing, we don't have a lot of influence to change the way people source raw materials, the way they extract, minerals from the ground or perhaps harvest wood. We can perhaps say that we want to make sure that there's a certification in place when we source wood or something, but we may not be able to influence certain things. Likewise, in manufacturing, we may not be able to change the way they smelt aluminum, but we can insist that there are environmental management practices in place. So our ability as designers is somewhat limited in being able to do certain things. What we do have a high degree of leverage to do as product and packaging designers is we can specify materials, we can determine what combinations of materials, we can help determine how efficiently materials are going to be used in a particular design, and we can also understand the system that we're designing for, and particularly if we're designing for end-of-life systems, we have a high degree of ability to design for those. So those are the types of areas where designers, I think, have a lot of latitude to influence those parts of the systems. So design for recycling, in my mind, is really a subset of design for environment. And it's when the design priority is really focused on a particular part of the system and a particular part of the end-of-life system, specifically the recycling part of recovery systems. And the first part of designing for recycling is understanding that recycling system you're designing for. And that recycling system can vary from region to region. Designing for recycling, for instance, in Europe could be quite different than designing for recycling in the United States. Our collection systems are different, our bin systems are different. So you need to understand the system that you're designing for. You need to understand the material issues that you are designing for. When is PET, for instance, PET, and when is it not PET? That means understanding what are the best practices and are defining those. A MRF may have best practices, and a reprocessor may have best practices, and those two may be different, in fact. So one needs to go and understand, you know, from those practitioners what they consider the best practices. As I think many of you who are local governments and state governments know, all recycling is local, and you need to understand what are the conditions in localities, and those localities can vary rather dramatically. And urban recycling is quite different than rural recycling. So somebody who's designing for recycling needs to know when they've come up against their 60-40 rule or their 75-25 rule or their 80-20. When is somebody going to decide that they have you know, reached a point where they think they have met a point where they've met good enough, so to speak, where they've met a threshold where they think they have designed for enough systems. And I think that one of the key issues that I have seen is designing for collection versus designing for recycling is a very key issue. Designing for getting something into a bin versus designing for something to making sure it's going to get reprocessed can be an exercise that is often quite different. I think I've talked to packaging designers who were quite shocked to find out that they thought that they were going to get something in a bin, only to find out, in fact, it would never get off the conveyor and actually get recycled. So I think understanding those issues is quite important. So those are just some very high-level points on designing for recycling. I know Green Blue and the SPC is working on a really nice design guideline for design for recycling. I'm looking forward to that document being released. But I think that one of the this is where we're going to segue into sort of the introduction of what is the role for life cycle assessment now, and helping to answer some of the questions around, you know, how can LCA answer questions around recycling and around material selection. So we're going to start to move into some of those. So at a very high level, one of the very first questions you need to know, and LCA almost, I think, more than any other science, is fraught with lots of jargon. So I'm going to try to not lay too much jargon on you, but one of the first things that you get exposed to in LCA is what are the boundaries of the system that you're going to study, really of the problem that you're looking at. What are the boundaries of it? You have to draw a box around your problem. Most LCAs are considered a cradle-to-grave analysis. So you can see I've used sort of the analogy of the life cycle thinking from sourcing to end of life to show a cradle-to-grave analysis. But you can also do a much more limited LCA of what someone might call a gate-to-gate type of analysis, where you're looking at just a small part of a full LCA. We might call that a more limited LCA. And the level at which we study LCAs is called a unit process. And it's just the level at which we sort of evaluate information. We look at it by process. We look at inputs and outputs of a process. And it's looking at inputs from what we call the technosphere. It might be purchased inputs. And we look at inputs from nature. That might be water that comes from a river, or inputs from nature that you don't have to buy. And then we look at things that go into that process, and then we look at emissions to land, air, and water. And in this particular process, in this diagram, you'll see that I have inputs, energy, water, inputs coming from the top of the diagram, and then emissions to land, air, and water are at the bottom. And from the left, I have inputs from upstream processes. So that's really inputs from the value chain. And then I have products coming out to the right. So this is just showing you one unit process. And the neat thing about LCA is that LCA lets you put these processes together. So you're able to aggregate processes across a value chain and then add up those inputs and those emissions across a value chain. And you can do that from cradle to grave, as shown in this diagram, or you could do some subset of this diagram. And what you can find is that you can model very complex or very simple systems. And it can give you very detailed or very simple answers, however you want to do it. But it's a very powerful tool to inform decision making. And I think one of the things that it can help, I think, is as we talked about when we looked at that life cycle thinking, with all of those various issues that you see when you look at sourcing and manufacturing and use and end of life, we look at a variety of different types of environmental impacts that can happen in all those different life cycle phases. And what life cycle assessment can help you do is actually add up all those different types of impacts from all those different phases of the life cycle. And you can look at them from global warming potential, acidification potential, ozone potential, human or ecological health impacts, land use impacts, water use impacts. These are just some selections I put up there. It's very, very powerful that way, that ability to look at multiple environmental impacts. So a carbon footprint is just looking at a single environmental attribute, global warming potential across a life cycle, a cradle-to-grave assessment. A water footprint is just looking at water use impacts across a life cycle, a cradle-to-grave assessment. But a big, important footnote to all of this is that a life cycle assessment is only as good as the life cycle inventory data that's used in the analysis. So there can be great variations in the quality of data for any individual process. As you might imagine, any of you who've ever looked at sort of compliance or reporting data, some data can be quite good, some data sometimes is maybe not so good, and life cycle inventory data is no different. So I thought it would be helpful to just maybe show you a quick example of a life cycle assessment that was done for EPA that asked a question, what are the impacts of delivering 100 pounds of fresh tomatoes to market? And this was just an interesting sort of study to look at how much of those impacts are packaging related and how much are related to the tomato product. And is there an optimal packaging option for delivering these tomatoes? And I just thought this would give you a quick snapshot of how maybe LCA can be used to get to some of these types of questions. So this, you know, hopefully this is beginning to start to look familiar to you. So in this analysis, the life cycle of tomatoes were looked at, including growing the tomato, packaging the tomato, transporting it, packaging it, storing it, transporting it to retail, selling it, and then the end of life. However, the consumer use piece and then disposal of tomatoes were not included in the analysis. So there were certain pieces that were left out. So this shows you in a little bit more complicated view of what a boundary looks like when you do an LCA. So it shows you what unit processes were actually included in the analysis. So in the quantitative analysis, so in the boxes, you can see those little boxes show the unit processes. So 3 different packaging types were included in the study. There was a loose tomato version, which is in the middle, which is in the polyethylene bag. There was tomatoes in the PET clamshell, which is the far left. And then there were a polystyrene tray with tomatoes shipped overwrapped with a polyethylene overwrap, which is on the far right. In all cases, they were put in the secondary corrugated shipper, which is in front of you. I don't have a slide for this, but the PET clamshell was the heaviest package. The polyethylene loose one was the lightest, and then the polystyrene tray and overwrap was the medium weight. So in this model that we're looking at, in the United States, most tomatoes are grown in the San Joaquin Valley. And the end market that we're going to is Chicago. Wayne, can you click the down arrow once, and I think a line will show up. There you go. And they're being transported in a refrigerated truck, 2,155 miles to Chicago. And they're then put in cold storage or something for a couple of days and then shipped 20 miles to retail where they are consumed. So big transport distance and then retail. So that was an assumption for the model. So I didn't want to belabor this study, but I just took one example, one of the packaging examples. It's actually the lightest packaging example. And I wanted to show you what the greenhouse gas emissions for the loose pack tomato example look like. So this is the greenhouse gas emissions for each phase of the life cycle. So growing tomatoes, packaging and manufacture, storage, transport, and the end of life. And you can see that each of the bars is sort of broken out by different things. And you can see by far the overwhelmingly most significant piece of the overall life cycle was transportation. And of that, tomatoes were 96%, and the packaging was 4%. The second most important was tomatoes, and you can see of that, I believe 47% was irrigation, 47% was fertilizer production application. The third most significant was packaging manufacture, and of that you can see 74 was corrugated, 14% was a polyethylene bag, 12% was a polystyrene liner. So I just wanted to show you that because that was pretty stark, the contrast of the relative importance of that. And I think what that's telling you is the transport of those tomatoes was very impactful. They're very heavy. They have a lot of water on them, and shipping them 2,155 miles was, a big deal in this particular model. And then growing them was also very impactful. This is, though I should say, just the greenhouse gas emissions perspective on it. I didn't give you all the other perspectives on it. So what I wanted to show you then was they wanted to show how important was the packaging relative to tomato growing and transport overall. So if you looked at the overall impact of growing and transporting tomatoes, how important was the packaging to the the growing and transport of tomatoes. And what you can see is that the PET clamshell and its transport on all impact categories, global warming, acidification, respiratory impacts, and smog, was the next most important. But it was quite, relative to the tomato growing and transport, it was quite, you know, less important relative to the tomatoes. The next lowest was the polystyrene tray, and then the least impactful was the loose tomatoes and transport. So there were a couple of conclusions from this study that EPA made. You know, they did this study to talk about how LCA could help with the sustainable materials management. You know, that LCA helps establish a framework, you know, with an integrated assessment of packaging and product from a life cycle perspective and over multiple impacts. But there were a couple of other conclusions from the study. One was that, and I didn't put the slide up here, but it showed that loose packaging actually had the biggest product losses. So that actually ended up not being a good choice from packaging because it had the highest loss rates. The polystyrene tray with the overwrap actually ended up being the best choice for packaging. So that was kind of interesting. And what they did say was they were surprised that relative to the product, they were surprised that the packaging over that transport distance actually had such a big impact. So they wanted to actually go back and see why the packaging did have such a big impact. It did show that transport was a very important indicator. I did want to just point out that that is probably, you can't draw a general conclusion. One should not just think that your tomatoes should necessarily be local, because I know John did a study on tomatoes that actually showed that if tomatoes are grown in greenhouses with natural gas, that can also negate that conclusion. So we're going to move on to John's part of this presentation, but I just want to say, so we're going to move on to really how does LCA handle recycling and material recycling loops? Is recycling always the best option, and can LCA give you some insights on that? How can LCA support material selection decisions? And can it help inform our knowledge about material end of life? How can LCA help us account for and manage waste streams? And how can it help our actions, inform our actions and technologies to improve end of life material efficiency? So with that, I'm going to turn it over to John. Thanks very much.
The first main point I wanted to emphasize was that there's a benefit from recycling and other beneficial uses of end of life, and that's a lot of what we'll be talking about in terms of identifying how we identify this benefit and how we include it in the life cycle assessment. So what's shown here is a fairly simplified life cycle of a product where you have production of the materials, manufacture of the product, use of the product, and then collecting it at end of life. And then we have a detailed view of some things that can happen at end of life. And so for a variety of options like recycling, waste to energy, reuse, and landfill, what we're showing here is a treatment process, and then also a co-product coming from that treatment process, which is a beneficial energy or material that can be reused. And so in a life cycle assessment, we might choose to represent that beneficial material or energy as though it's replacing something else in the economy. So if we're producing, for example, new energy that's an output of the system into the economy, we might choose to represent that we've avoided the production of an equivalent amount of energy from other means. Similarly, if we're providing, for example, a kilogram of recycled aluminum, we might make an assumption that that's replacing a kilogram of virgin aluminum, and therefore the impact of producing that new aluminum has been avoided. And that's the general benefit that we're characterizing at end of life with recycling, as well as with other beneficial uses of material. So the problem statement that we're trying to address here has to do with how we assign that benefit. So if you picture, for example, a PET bottle and its life cycle, you have the production of the PET, its life as a bottle, and then it gets recycled. And when it's recycled, there's a benefit that occurs from it being recycled. That material will then go into a second life cycle, and we can imagine that might also be a PET bottle. It could be something else. But that second product uses the recycled material, and so it might also think that it should claim some kind of benefit from the use of the recycled material. And so you have that shared process of the recycling that's crossing these two different life times of the material, or product life that the material enters. And if both of them want that the benefit that occurs from the recycling, there's potentially a conflict or an inconsistency that can arise. The issue that arises is that we can't assign that benefit twice, and so we can't give 100% of the benefit of recycling to both of those systems. And if we do that in the way we represent a system, we're in danger of having some pretty large inconsistencies in our modeling. And so this is the fundamental problem with recycling that causes some difficulty for LCA, and there's a variety of different ways people attempt to solve this issue. And I wanted to spend a few minutes describing some of those to give a sense of what you might see as you're looking at different ways of modeling this or trying to interpret information from LCAs on recycling. So there's a variety of options that you can consider for how to address that problem. And there, in addition to these, there's others that have been attempted in different studies. But these are some of the ones that are more common. There's a potential to assign all the benefit at the end of product life. So in that case, it would be the bottle that is recycled that would be assigned the benefit of the recycling, and no benefit would go to the use of that recycled material. You could also potentially do the opposite, where you give all the benefit to the use of the recycled material and none to the act of recycling. You could potentially split that benefit in some arbitrary manner. One common choice is simply 50-50, and so you give 50% on each side of that divide. Another approach that's been used is to try to base the allocation of that benefit on the economics of the system, so that you're looking at the supply and demand and trying to assign the benefit based on what's driving the system or the limitation of the use of recycled material. Another potential option is you could divide the impact up among the number of lives that material might undergo. In the picture we have here, there's 2 lives. Potentially that material could be recycled again at the end of the second life, and there'd be a third life, and so you might divide it then by 3. And that's another option that can be explored and is used in some cases. An important question to try to consider when you're identifying which of these or any other method might be the way to approach this is what you're trying to achieve with the project. Is your goal to try to produce an even or what you might say a fair assessment of the impact? Are you trying to understand the effect of actions and looking at the consequences of different actions in the system? And that question of what are you trying to do with your study or your accounting system might be one of the things that influences which of these choices you ultimately look to implement. So very quickly to summarize those different options, if we have all of the benefit at the end of life, the rationale usually for applying that would be that it's approximating what we would get from the economic approach if it's a supply-limited market. So if the market for recycled materials is limited by how much supply there is, it would make sense to incentivize the creation of new material, which would basically be giving the benefit to the system that's giving the recycled material. The benefit of doing that is that it's fairly simple to implement. In cases where you do have a supply-limited market, it has a relatively good rationale for doing that. And many recycling markets are, in fact, supply limited, where the material that is generated does get used relatively easily, and there's not a lot of it accumulating. And so it's a reasonably defensible method. One of the potential drawbacks is that if you don't have that economic argument, it's a bit arbitrary, and there's not as solid a foundation for it. Another drawback is that it doesn't give any emphasis to the use of recycled materials. And so in some cases, people don't like this method because it tells you basically that there's no benefit to using recycled material. And in fact, believing that that's true is one of the reasons why people might advocate for this method. If you hit next, please, I think it'll highlight the next one. The opposite of that would be to assign all the benefit at the beginning of life. If you are in the case where you have a demand-limited market, this would make sense to do. The most common reason this is applied is because the way most life cycle assessment databases are set up choose this method by default because it provides a fairly clean break between one system and another. It's often referred to as the cutoff method because it divides the systems fairly straightforwardly. The benefit of this approach is that it does give a strong emphasis to the use of recycled material. And so in cases where people are, for one reason or another, trying to incentivize the use of recycled material, this is the method that would likely show you the biggest benefit from using recycled material. A drawback can be that without that economic argument, again, it's somewhat arbitrary why you would choose this and not the other, the prior one or any of the other methods. You could hit next, Lisa. Another option that I mentioned before would be to just split the benefit in half and send 50% to each of the two systems in question. Oftentimes the rationale cited for this is that it seems fair. It's kind of a political solution. It's aesthetically pleasing in that you have half on one side and half on the other, and people tend to find balance to be a nice thing. Of course, what we're trying to do here is more science than politics or art, and so the idea of fairness isn't necessarily one that resonates that well in science. And so I think that's one of the drawbacks is that it is in fact a fairly arbitrary choice to do the 50-50 in most cases. But the benefit of applying this is that you do see some benefit at both ends. So it does give some incentive to recycling materials, and it does give some incentive to using recycled materials. You could hit next, Lisa. Another approach would be to base the allocation on the market economics. And so in addition to the top two, which, as I was mentioning, you could try to justify based on the conditions of the market, you could also make a much more detailed market analysis and choose an allocation that's somewhere between the two extremes based on what those economics would tell you. And this is a calculation you do based on the prices of virgin and recycled material on the market. One of the benefits of this is that it attempts to reflect fairly accurately the consequences of different actions. And so within LCA, the type of approach we often refer to as consequential, meaning that it's trying to predict what would be the consequences of your action and assigning impact based on those consequences. And therefore, it has a reasonably good rationale or justification for including it. The drawbacks can be that it's difficult to compute because you need a lot of economic data. That economic data fluctuates, and so from time to time, you might get a different allocation, which can actually be a little bit frustrating. And you might find in some cases that the total impact doesn't balance across your system. If you hit next one more time, the last one on the list here is to do the allocation based on the number of uses. For how much sense this seems to make, it's actually a relatively rarely applied approach. The rationale behind it is that you're dividing the impact of managing and producing a material evenly over the different lives it undergoes. So if you could predict that a material would enter 4 product systems before ultimately being landfilled, you can divide the impact of producing it in 4 and assign a 4th to each item. The benefit is that there's a fairly good rationale for doing that. It's fairly consistent. It's not dependent on the market fluctuations in prices, and it's quite easy to understand and explain. People tend to pick up the the idea of this relatively easily. The drawback can be that it's relatively difficult to calculate. Depending on the data you have to have relatively good data on the rate at which material is recovered and recycled within the economy. And also, you have to make assumptions about what the rate would have been in the past and the future, depending on the lifetime of the products you're talking about. And so in some ways, it does take some assumptions and some working with incomplete data to implement that. So this is an example of applying this, keeping with our system of a PET bottle. This is showing the gradual impact in terms of climate change over the lifetime of that bottle at different stages based on those different recycling allocation approaches. And this is a bottle, I should have mentioned, that has, I believe, 50% recycled content in it, and they end up being recycled at something like a 50% rate. And so we have some benefit potentially to be assigned at both ends. And this shows you what difference you would see with those different recycling allocations. And so one of the things that might strike you is that we can make a big deal about these differences, but does it really make a difference in our results of the LCA, or do you end up with some fairly fine distinctions but not really differences in conclusions? And in many cases, that's in fact the case, and I think that's probably the most important question to ask is this choice of methodology an important determinant for the study in question? If you hit next, Lisa, I think there's a little bit of text there. So even though the differences in the baseline are relatively small, one of the things that that's important to notice is that the approaches differ in how things change under changing conditions. And so one of the things you can help draw out by assessing the differences in these methods is how the system responds to different things that are changing in the modeling. And if you move on, Lisa. And a key need is to be able to apply an accounting method that's consistent and that you can use consistently across a certain decision-making process. And of course, if you have stakeholders involved, that they buy in and are appreciative of the choice of methodology. And so there can be a need to defend the way you've done this in the work that you do. And so one of the things to understand is that the different methods will give you a fairly different response to changes in recycled content and to changes in the rate of recycling. And so this is an example of as you go from no recycled content to 100% recycled content, how the impact, and again, this is using climate change just as an example, how the impact changes over that time frame. And you see, for example, if you're giving all of the benefit at end of life, there's no change at all. If you're giving all the benefit at the beginning of life, you see a rather drastic change. And the 50-50 and the number of uses are somewhere in between. And if we go to the next slide, this is showing something similar, but the x-axis now is the frequency with which the bottles recycle. And so now you see the opposite, where giving the benefit at the beginning of life results in no change instead of a drastic change, and there's a much more drastic change for giving the benefit at end of life. And again, the 50-50 and the number of uses are somewhere in the middle. And so this issue of how the system's responding to the changes that you make can be one of the key determinants in distinguishing between these different methodologies. So to give an example of actually applying this in trying to help communicate a result or defend a result, I wanted to use an example I use fairly frequently because it gives, I guess it gives a good basis for making a number of points like this. This is a comparative life cycle assessment we conducted a few years ago, comparing a high-speed electric hand dryer with drying hands with a standard electric hand dryer and then with paper towels. And this is the baseline set of results looking at 5 different environmental impact categories and comparing those 3 systems, including paper towel with and without recycled fiber content. And what you see is that the high-speed electric dryer is a much better performer than the other systems on all those different indicators. In most cases, more than a factor of 100% better on each of the indicators in terms of impact. And there's a number of different questions you could then ask in terms of the sensitivity of that result and what assumptions have come into it. One of them might be how have you handled this question of recycled content. And so if we go to the following slide, we show a sensitivity test where we've applied 3 different approaches for doing this this allocation, including giving all the benefit at end of life, all the benefit at the beginning of life, or splitting it in half. And so you're testing the extremes and then also showing the midpoint. And then you see within each of those also varying the recycled content between 0% and 100%. And what we find is that if you're comparing with the standard electric dryer, which is one of the things that I think makes this example quite interesting, is that you do actually see an importance of this issue. If you were trying to make a comparative assessment between the standard electric dryer and the paper towel, how you handle this recycling allocation might in fact change your assessment of that. I think in all of these cases, you might decide that the difference is too close to really make a strong comparison between the two. But certainly it is in the range where that's going to affect your outcome and your conclusion of the study. Whereas in comparison to the high-speed electric dryer, it doesn't really matter how you do the recycling allocation. You still have a fairly definitive advantage from that system versus the paper towel system. And so in that case, you could fairly clearly state that how you handle this recycling allocation is not a very important question to ask in terms of that system. And I think that's one of the benefits of being able to go through these scenarios is you can potentially dismiss questions like this as not being relevant or not being important in determining the outcomes of your study. There's a handful of other questions I thought would be interesting to point out with regard to recycling, just as ways of helping people think a little bit about this issue and how we represent it. One of the questions I think that's worth asking, and again, we're using PET models here as just an example, but the same would apply for other materials, is to ask what's the benefit of recycling PET? We assume that the benefit is essentially equal and opposite the impact of producing virgin PET, with the idea that PET is replacing new PET. But it is worth asking the question of what do the recycled bottles replace? Are we actually replacing PET? And so in this case, we can go to an industry association, NAPCOR, which collects data on what happens to recycled PET and look at what things are made out of it. And some of the more prominent uses are fibers, which are used in things like carpets and other fabrics. Those, for example, are generally replacing PET in addition to some other plastics. It's used in sheets and film, where virgin PET might also be used. There are some engineered uses for things like park benches. That's something where you might be replacing wood or metal as opposed to PET. There's also relatively high use and a growing use in food and beverage packaging, as well as some non-food bottles. And that's the case where you likely are replacing PET. Potentially some other beverage packaging like HDPE might be the replacement there. And so if you hit the next button, Lisa, conclusions we can draw from that are that in most cases it does look like recycled PET is replacing virgin PET, or there's at least a high likelihood that it would be. And so it would seem like if we're not using the recycled PET, even in a bottle-to-bottle type of application, it's very likely still replacing virgin PET. And so that assumption seems to be valid. But you might find from some of that market data or data on specific uses of the PET where it may not be justifiable to assume that you're necessarily replacing one-for-one the virgin product. And so it is worth doing a little bit of that research to try to justify that assumption. Another interesting question to ask is it advisable to make new bottles with the PET? And again, this could apply to a variety of different materials. And you hear oftentimes terms like upcycling or cradle to cradle as things that people generally use to express the idea that if we can continue to recycle something back to its existing use, or maybe even better, and the idea of upcycling is if we can rank uses, would be to move it to a higher use. That's necessarily a better thing. And I think there's reason to question that as well. Not that it's necessarily wrong, but that it's at least worth investigating. And so if we think of a comparison of taking a PET bottle and making a new food grade bottle with it versus using that to make carpet, and we plot those systems out, what we find is that in either case, we're going to want to supply the economy with a new drinking bottle and with carpet. And so to do that, we'll need two inputs of virgin PET, one recycling process to take place with the recycled PET. And from that, we can end up with two uses of the bottle and one use of the carpet. The only difference in those two processes is that we very likely need a different process to get to the food grade PET. And that might well be a recycling process that uses more energy than to develop a lower grade recycled polymer, which could be used in carpet. And so this isn't something that we have very good data to support because we don't currently have very good information on the difference in energy use in the food grade versus non-food grade PET in this case, but it's something where you could ask the question and you might identify that maybe it in fact makes more sense environmentally to take that used plastic and make carpet from it because our economy anyway is using a lot of virgin PET, and so why not use the virgin PET in the bottle rather than taking the virgin PET to make carpet. So again, just a question that might be worth asking and have relevance to other systems. This one gives an example of how you might then use some of this recycling information to select different materials, going back to echoing some of Ann's thoughts about product design and material selection. So if we start by just looking at the material impact, if you go to any of a number of different databases that are used for LCA, they'll give you, for climate change, for example, as well as for a lot of other impact categories, numbers that you could use or results. And those are just the impact of producing the material. And so you might start with that information and say, well, which of these is least impacting to produce? If you wanted to get a little more sophisticated, you might look at what happens to that material at end of life. We realize that, the material is recyclable, and actually we can actually look at what the benefit is of recycling that material and include that in the analysis. And so in this case, if we do that, it might change a little bit our view of the different materials, whereas originally the metal was looking very poor. It now might be looking a bit better if we take off that impact based on the recycling of the material. But then we might think a little bit more deeply and say, well, it's recyclable, but that doesn't necessarily mean it's entirely going to be recycled. And so even though the metal might, if you do recycle it, have as low an impact as the plastic, we're not sure that it will be recycled that much. And so it would make sense to go gather some information about the likelihood that the product you're looking at will be recycled. So we might want to go find some rates of recycling for different materials. And with all of that, we could do a quick computation and figure out what would be the total impact on average of using those different materials in that application. And so in this case, we might imagine maybe it's a beverage container we were just thinking about, and we're asking the question of, is it better to use the plastic, the glass, or maybe an aluminum? These are all just fictitious numbers to avoid any kind of controversy. But the idea here is that what this, the conclusion you might draw here is that it might in fact make more sense to use the more intensive metal material because you're getting a high recycling rate from that system that justifies having a higher impact of producing the material. And so if we think through all those different steps in the system, we can bring that recycling information into our material selection and think a little bit more carefully about it. And it might be worth thinking about the question of what if instead of a beverage container, that's the base of a paintbrush we're talking about. And so I'm going to assume that in many cases, paintbrushes aren't recycled, they're thrown in the trash. And so we're probably looking at more or less just that top line in making that selection. And so if all else is equal, we're not worried about aesthetics or function or anything else. We just need a material to make that paintbrush handle from. It might make sense to go with one of the plastics in that case rather than the metal. And so it's important to consider what product are you designing and what's likely to happen to it when you're thinking about material selection. It's also important to remember, and Anne pointed this out a few times, that the environment's much more complicated than a single scale. And so this is obviously a very oversimplified approach with just one set of numbers, but oftentimes, or always in LCA, we have a variety of different impacts to consider, and oftentimes those don't lead you necessarily to the same conclusion. Just one example to mention very briefly is that of paper recycling. Many people may frequently hear it said that there actually is not much benefit to recycling paper, and that's actually a conclusion that's frequently reached using life cycle assessment, where and a number of different databases and assessments are fairly consistent on this, that you often use as much energy in generating recycled paper products as you do in generating virgin paper products, depending on the product and the process, of course. But because of that, your climate change impact and your energy use impact for recycled paper products can be nearly as bad and sometimes worse than the virgin product. But oftentimes people who are discussing that result are really focusing only on energy or only on climate change, and they're not looking at a broad range of indicators. And if you look at the environment in a bit more complexity and think about things like land use and biodiversity and water use and several other impact categories, the recycled paper actually looks fairly good in those impact categories because you are saving trees, you're using less land, you're using less water in the pulping of the virgin material, and so many of these other indicators can look quite favorable. And so it's important to think about of the environment in that way, where we have a lot of different issue areas to pay attention to. I think I've got just one more slide, and I always like to give people a chart that's so big you can't read the text on it. So this is my attempt to do that. What this is showing is just an example of a project we had done a few years ago where we were looking at handling materials at end of life, and I wanted to use it as an example of how you could pull together this information to help manage and understand what's going on in the fairly complicated material chain. This is looking at the end-of-life disposal of all the materials in a building and what would be the benefit of trying to recover and find beneficial uses of those materials. So in this case, you can scan down the list and identify a few things like wire and steel products and the glass wool and the wood siding, where there's a reasonably high benefit to be obtained in many of the indicators from that material, whereas for other materials there's not as much benefit. And so this information might be something you could use, for example, to set up a material recovery program. You could also use this type of information to be accounting over time the amount of benefit achieved by efforts to recover and recycle different materials. And so the LCA can be a very good way to put metrics on programs like that.
Okay, thank you, Ann and John. We are now going to field some questions from our presenters. Again, if you have a question, please enter them in the GoToWebinar dialog box. Our first question is, can you explain product loss more? I believe that question goes to Ann.
Yes. So on the product loss, it was on the loose PE bags. You know, on those bags, there's no structural support in those loose bags. So the tomatoes are just in the bags, then in the cardboard box. So as you can imagine, those tomatoes are getting mushed as they're getting transported and then probably stacked in the distribution center. So I think you're getting a lot of bruised tomatoes. I think that was like 11% of the tomatoes were lost before they got to market. So that's pretty high product loss, probably unacceptable product loss. So that means that was not an effective packaging format. It didn't meet, you know, performance expectations. So you have to count that in, you know, when you're looking at your analysis.
Next question is for John. How do you account for subsequent recycling uses? For example, carpet recyclers currently do not have technology to cost effectively recycle PET carpet, whereas carpet made with nylon can be recycled. In contrast, our PET bottles can be recycled multiple times. Including this information requires including more than one subsequent round of life cycle information. Do LCA models have the capacity to do this now?
Yeah, how you would handle that would depend on which of the ways of modeling recycling we were talking about. Obviously, you want your model to be realistic, and so it makes more sense to try and represent what is or will be recycled rather than what's recyclable. And you'll often hear materials referred to as recyclable when in fact they're recycled at very low rates. And it makes sense in your model to be thinking about what's actually happening in the economy or what you predict would happen when the material you're putting out there will eventually meet its end of life. And so if you have the case of a PET carpet where it's not generally being recovered and recycled, it would make sense to assume a fairly low recycling rate, which likely would be a fairly low benefit. And you'd represent most of that material as going to a landfill. In the US, you probably would see maybe 15 or 20% of it going to energy recovery, and you have a little bit of benefit there. If you were taking the approach where you're trying to quantify how many times the material is used, it can be useful to know what the markets are for that material and the types of uses they would undergo, and have some sense of how much of the material that's being put out there is being reused to try to get a best estimate of, on average, how many lives would a PET resin entering the market have. And so knowing that maybe 30% of recycled PET is going to carpet, which is recycled at almost 0% rate, would help you calculate that question of how many lives would the carpet or would the PET undergo before it's disposed of, if you're choosing that approach.
Okay, next question. This is for both. Have any of you completed an LCA of single-use plastic bags, single-use paper versus reusable bags? Paper versus plastic.
No, we've not done a project looking at that. It's kind of a classic question, and I think the
AF&PA
question might have also included the question of reusable, which is another aspect as well.
Hasn't AF&PA done it? They did a big bag study. Looking
they might have. I know there has been a number of them completed in the past, and one thing that's really interesting about these systems is you have, in the case of the paper, a renewable, relatively heavy weight, but recyclable or recycled product, whereas with the paper you have generally non-renewable but very lightweight option that's recycled at a fairly low rate. And so I know a number of studies that have done the math and come up with some differing results, but generally in this case it seems like the lightweight option looks very good in the LCA results.
Yeah, I think NCASI has done a paper bag study for AF&PA, and I think I believe ACC has done a plastic bag study. I'm not positive, but you probably could look and see. I'm not certain. I know I personally have not done those, but that is the classic question.
And just a comment, I mean, in your tomato example, you didn't look at the end of life issues. So when you look at that, if you include that in that analysis, PET probably would probably come out better because it's more recyclable than your polystyrene.
Well, when you looked at the PET, the recyclability was actually factored into, I took that slide out because it was an extra slide, but PET clamshells are recycled at a pretty low rate. And when that study was done, that was actually sort of factored into the characterization of the PET that was in there. So that was one of the things I think was taken into consideration.
Interesting you say that. Interesting you say that because a future webinar will address PET thermoform products and the increased recycling of those materials. So, okay, next question, and you might have touched on this. What is the answer to your hypothetical? Is it better to recycle PET bottles into food grade PET bottles or into carpet/fleece?
Could you repeat the question?
What is the answer to your hypothetical? Is it better to recycle PET bottles into food grade PET bottles or into carpet or fleece?
This is also one that we do not put enough work behind in order to give a definitive answer. I think the point I was trying to make was that it's at least questionable whether trying to make food grade recycled plastics is a very good idea, at least when we're in an economy where we're still using a very high amount of virgin plastics, because you have to invest a lot more energy in getting the recycled materials. And when I've heard about some of the processes that people undergo to get recycled PET, it often includes not only investing a lot of energy and sometimes chemicals and solvents, but also washing the flake with acid that actually can cause you to lose something like 30% of the material in just cleaning it. And so there seem to be a lot of inefficiencies in trying to get back to that high-grade material. And so my thought, without having done the project in enough detail to give it a definitive answer, is that it probably makes more sense using the virgin in the food grade and to take the recycled polymer and do something that's not as demanding of quality with it.
Okay. And here's a comment basically that confirmed the studies on paper and plastic. Both NCASI, which represents the paper industry, and the ACC, which represents the plastic industry, have their own studies.
Oh, good.
And I believe that is it for the questions. Once again,
one comment on John's, one thing that a very interesting comment that Interface, who makes PET carpeting, has said, along those lines, is that the rate with which we are sending polymers to the landfill is speeding up. The time frame of taking virgin polymers and putting them in the landfill is getting faster and faster. And I don't know how LCA takes that into account, John. And I think that's a really interesting question about how do we count for time in LCA in terms of the length of time you keep something resident in a product cycle, sort of that, whether it's a durability time frame, because they were talking about in their carpet cycle, it used to take something like 13 years for virgin polymer to end up in a landfill, and now it takes about half that time for virgin polymers to end up in a landfill. And I don't know how LCA answers that question, but I think it kind of gets to that bottle versus carpeting issue a little bit.
Anything else, John?
No, nothing more to add.
Okay. All right. Thank you again, Ann and John. We appreciate taking the time to making these presentations. This webinar, like all the webinars in this series, have been recorded and will be made available on both the NRC and RMC websites. And thank you again for joining us. We hope you'll join us for next month's webinar scheduled for Tuesday, December 18th at 1:30 Eastern Time. And have a good day.